Dr. Neeta Chan. It is my privilege to introduce about Professor Dr. Neeta Chan. Dr. Neeta Chan, Professor, Department of Chemical Engineering, St. John's College of Engineering, Kochi, and she has obtained her PhD in Polymer Technology from Kochi University of Science and Technology, and she has more than 27 years of teaching and research experience in the field of polymer science and technology. She has been I hope you are enjoying your Fdp at Kochi Cipet. I was also part of Kochi Cipet. Currently, I moved to St. John's Engineering College. As I have a background of chemical engineering, and actually I am a blend of chemical engineering and polymer technology. So I use my knowledge in both the area to have interest in polymers. So I am continuing my research in polymers also. So hope this title given is biopolymer and composite material. So I am actually interested in this topic. That's why I planning to take a manufacturing process for this biopolymers. And first of all, I thank Cipet and especially Dr. Manjula Madam for inviting me to take a session for this activity. Thank you, Madam. And we will start our session, and hope it can be an interacting section. Without one side, it will be very boring. So please interact if any things are there, because you are all faculty only. I am also a faculty. So you please interact, otherwise it will be boring. So as faculty members, please get maximum out of it. Okay. So as an introduction to biopolymer, you might have already heard about biopolymers. Why this topic has emerged, biopolymers? Because we are all familiar with the polymers, polymer era, and it was a so convenient material. It was so convenient material that it got popularized in a very fast rate. And we are living in a world we cannot live without any polymer product. Plastics or textile fiber, these materials from our daily routine. Because every item what we are seeing around is one of the way polymers only. So even our body also is full of polymers, that also we know. So we cannot live or we cannot move away polymer from our life. And that's why as polymer has started coming into the field, it gained lot of only because
these are biomaterials.
No, it's not biomaterial, it's only normal petroleum, the normal petroleum only. But why we are not going, this first and foremost thing is the cost. Cost will be higher. Okay, so if you are making 10 rupee bottle, you may be going for 50 rupee bottle. So people may not survive in that cost. And in country like India, the food sources, food scarcity is available. People are not preferring to making bottle instead of having food. So food item we have to take, then we have to make for the bottle. Okay, in advanced countries, they having lot of food resources are available, and they will be storing the food for coming 6 or 10 years. Already they are stored. They having then season agriculture itself has to be improved. We are making 1 ton, then we have to go for 10 ton at least. Okay, so that sort of research, that sort of parallel work has to be done. Then only we can actually switch over to completely to biopolymer. If it is done, then it is okay. People have to start thinking about that. That's it. Okay, so now it is not making because raw material is costly and people are not ready to pay for that. We are going for the conventional. And how long we will go? One day it will end. One day all the petroleum resources will end. We have to think of the alternative. That's right.
People will not too much for cost, very economical and better quality. But so we are actually buying the product from other countries and then selling in India.
Yeah.
All products.
Yeah.
Instead of manufacturing here in India. Maybe we have started already the manufacturing, but not in that scale with
this nowadays all the biomaterial whatever we are available in India, we are getting from outside only.
either from Germany or China, from all the biomaterial, whatever biomaterial, see some of the names I already might have seen in the last. So some of the names you see, whatever names, actually they are not prepared in India. We are buying only, okay, because the reason is we don't have the resource. Okay, if we have the resource, then what is the resource? It is a biomaterial only. So we have to start more farming. China having more food reserve for the coming 6 year or 10 year. They having food reserve. So they don't have any worry because they can use biomaterial for making the normal conventional
The
pasta.
population of India is the big challenge, sir. Population of India is so much high, that is the challenge.
Yeah, obviously, because people need food. People need food. Okay. So if we are not having food and we are going for the making of bottles or textiles and etc., people start worrying about that. Where is the food? Okay. So if we having food, proper food resource, then only we can think about manufacturing these things. That's why I am telling food resource. This is the overall food items. Some of them are directly food items only. So people want food only. Okay. So country has to develop in such a way that there is more food and at least reserve for 2-3 years. Then only we can take some of them for making this. So still now we are not in that level. Still now we are not in that level. That's why. It is comparable.
And in three-layer extrusion, you said we can use that for puncture resistance. What kind of test is used for that?
Puncture resistance test is available as per the standard. It's available. You have to apply the film on a flat surface and it is bound there, and you have to apply vacuum from the top and you add any weight from the top. The puncture resistance test is available. Impact strength test is available. That is only puncture resistance. Impact only. Impact resistance. You add weight on that from different height.
Okay.
That is.
And also you said for PLA we use physical and chemical modifications for flexibility. We can incorporate PLA with PPAT and it will give good flexibility.
That can be a physical modification. A physical modification of simply blending with some other biomaterial or plasticizer can be physical method. There can be chemical method also. Chemical method means structurally we have to change something. PLA is a highly crystalline structure, isn't it? Because you have to disturb the crystallinity by adding some grafting and all, so that the flexible chains will make them more flexible. The crystalline order will be disturbed and it cannot be packed closely. So crystalline order disturbed and chemically grafting. That was the chemical ideas. Chemically grafting the material, but the process involved. That process involved grafting components, grafting of other chains, and catalysts for that, etc. That was a chemical modification proposed.
You mentioned about the coloring agents. Like since we are speaking about biopolymers and bio-based plastics, are the coloring agents used in?
It should be bio. It should be bio. There are a lot of coloring agents available. You can extract color from the bio, and you can buy when you are going to buy a color. Just see that whether it is a organic bio-based color or a synthetic color. Okay, synthetic colors are available. Bio color is also available. There are a lot of methods where we are extracting colors from the normal biomaterial. For example, beetroot we are extracting, carrot we are extracting, like that is available. It's better to go for a bio color also.
So this kind of flex board are mainly based on PVC. Is there any alternative? You can print.
Now it is switching out to cotton. Cotton cloth is taken. Then there are some rules also that it should not be synthetic plastic. You have to go for the paper or cotton. Cotton means degrading. Cotton is degrading.
I'm asking about like any biopolymer having good printability, because it's most of the PVC is for good printability. But if any kind of polymer or biopolymer blend having any kind of good printability.
This PLA is cotton. Cotton is biomaterial. Cotton is a printable material. PLA and the PLA is actually polar only. So printability is not a problem.
But the
crystallinity problem is there. That once you want to make it into film, only PLA or film grade PLA means the manufacturer itself is modifying the PLA to film grade. That printability is not a problem because it is already polar. So printability is not a problem. We can switch over to, but cost is there. Cost is there. Other better to switch over to paper or cloth, cotton cloth. PLA film means again cost will be there.
Space modified material is available in the market for
Which application? Huh?
blown films or
Blown film. Blown film. Currently, not aware about any material available as cellulose. Because cellulose is also crystalline. Highly crystalline cellulose. Again, we have to single material cannot be that flexible for making film. So currently, any grade, I am not aware about any grade available cellulose based. You can blend it. Modified celluloses are available. Modified cellulose, pure cellulose for films and all is difficult because it's highly crystalline. Reinforcement is okay. Reinforcement is okay. We can have a continuous fiber or a chalk fiber, whatever fiber may you can reinforce it. But originally cellulose for making film is otherwise in paper. Paper is a cellulose, it's a blend of this. That way you can make paper. Paper is not. Cellulose acetate is okay, but that is not also not that preferred. Cellulose acetate is also not that preferred, but okay, can go for it. Not for making film. Blown film is very difficult. The difficult thing is to make it to film because it requires transparency, it requires flexibility, it requires melt strength. So making a film is not that easy. Molding and all can be possible. Molding possible. Normal molding, casting and all possible, but making film is the toughest thing. So currently cellulose based I am not aware about anything available. But fiber based is available. Fibers are available. Reinforcement is available.
Like we can make bio-PE and normal PE.
Yeah.
But bio-PE is from the biological origin. But we will get the monomer and we polymerize it.
Yeah.
And we will get the film.
Yeah.
But finally, the both it is not biodegradable or degradable.
No, biodegradable. It's not biodegradable. Only we are saving the
Petroleum crude.
yeah
Free from
raw material stream. That stream only we are saving. When it is coming to PET or when it is coming to PE, when it is coming to PP, whatever, it will be the same. Then the recycling process that you have to follow. That is an alternate route only to make the final raw
But
material.
in the case of like
PLA.
not in the case of PE only, PE and PET,
Uh.
it is not biodegradable.
Not degradable. Final polymer is not biodegradable.
But in the case of that it is prepared by the degradable polymer like PLA.
PLA
We
is
can
degradable.
prepare from the crude as well as
Yeah, both.
But
PLA
both
can
are-
be prepared from petroleum also, petroleum resources also, from the natural resources also. But finally it's degradable. That is the best preferred method. Bio-PE, Bio-PP, not that preferred because only it is saving the root only. Final product is the same. Final product properties everything same.